In this lesson, we're going to learn how to use factoring by grouping, combined with greatest common factors and differences of perfect squares to factor a polynomial completely. This is the second video in a two-part series on this topic. If you haven't already watched the first video, I recommend that you start there before proceeding with this lesson. Suppose we want to factor the polynomial 8x to the third plus 20x squared minus 18x minus 45. We have a four-term polynomial and we can use factoring by grouping. We begin by drawing the 2x2 grid and writing each of the terms in the grid. Now that we've done that, we look at the top two terms and we factor out the greatest common factor. What is the greatest common factor of 8x to the third and 20x squared? 4x squared, so we write that out front. Now we use multiplication to fill in the additional spots around the grid. 4x squared times some number equals 8x to the third. 4x squared times what equals 8x to the third? Well, 4x squared times 2x. So we put 2x in the first position. Next, we have 4x squared times some number equals 20x squared. 4x squared times what equals 20x squared? 5. So we put plus 5 in the second position. Now we go down to the second row. Some number times 2x equals negative 18x. What times 2x equals negative 18x? Negative 9. So we write a negative 9 in the position on the left-hand side. Finally, we can check by using the multiplication of our final two numbers. Negative 9 times positive 5 equals negative 45. That's true, so we must be on the right track. Now we have our two factors, 2x plus 5 as the first factor, and 4x squared minus 9 as the second factor. We might think we're done, but then we realize that that second factor, 4x squared minus 9, is a difference of two perfect squares. That term can be factored again. 4x squared minus 9 factors to 2x plus 3 times 2x minus 3. Don't forget we had 2x plus 5 as another binomial. So factored completely, we have the result 2x plus 5 times 2x plus 3 times 2x minus 3. We first factored by using grouping and then factored the difference of two perfect squares. Here's a similar problem for you to try. This problem will factor by grouping first, and then there will be a difference of two perfect squares. Please pause the video here, try this example, and come back when you're ready to compare answers. Let's compare answers. We want to factor by using grouping, so we begin by drawing the grid, and we write the terms x to the third plus 2x squared minus 16x minus 32 inside the grid. Now we look at the top two terms across the top row, we find the greatest common factor. And now we use multiplication to fill in the rest of the spots. X to the second times something equals x to the third. X to the second times x equals x to the third. X to the second times something equals 2x squared. X to the second times what equals 2x squared? The number is 2. Now we go across the bottom row. Some number times x equals negative 16x. What times x equals negative 16x? Negative 16. And finally, we can check negative 16 times positive 2 equals negative 32. It looks like we're on the right track. Now we have our two factors, x plus 2 and x squared minus 16. But notice that the second factor is a difference of two perfect squares. That binomial can be factored further. X squared minus 16 factors to x plus 4 times x minus 4. Don't forget the x plus 2, that's also one of the factors. So when factored completely, the result is x plus 2 times x plus 4 times x minus 4. Now that we've seen factoring by grouping combined with differences of perfect squares, let's take a look at another scenario where we combine grouping with greatest common factor. We want to factor this polynomial, 10n to the third minus 18n to the second plus 40n minus 72. We actually in this case have a greatest common factor, and there are two different ways that we could choose to factor this polynomial. The first option would be to do as we've always done and go right to the grid, writing the terms 10n to the third minus 18n to the second plus 40n minus 72 in the grid. Now we follow the same process we've followed for every problem so far. We look for the greatest common factor across the top row, 2n to the second, and now we use multiplication to fill in the terms around the grid. We check the last terms, minus 9 times positive 8, to make sure it equals what we have in the last box, negative 72. And now we have the factors of our polynomial, 2n to the second plus 8 times 5n minus 9. But notice that we have a greatest common factor in that first term. We can rewrite that binomial as 2 times n squared plus 4. Don't forget the 5n minus 9, and now we've factored the polynomial completely. So if we have a polynomial that has a greatest common factor, it's perfectly fine to start with the grid and then factor out the greatest common factor from which binomial it exists in. But there is another choice. We could choose to factor out the common factor in the beginning, dividing each of these terms by 2. So we have 5n to the third minus 9n squared plus 20n minus 36, all of that times 2. And then we could take that pink polynomial and follow the process for factoring by grouping using the grid. Again, putting the terms in the grid, finding the greatest common factor of the top row, in this case n squared, and then using multiplication to fill in the numbers around the grid. This gives us the factors, n squared plus 4 times 5n minus 9. Don't forget the 2 that we factored out in the beginning. That's one of the factors as well. And now we have our polynomial in factored form. The important lesson here is to notice that no matter which way I proceeded, whether I use the grid for factoring by grouping in the beginning, and then took out the common factor, or I took out the common factor first and then went to the grid to do factoring by grouping, I end up with the same result. Either method will work. Let's see if you can do a problem like this. Here's a polynomial that has a greatest common factor and grouping. Please pause the video here, factor this polynomial completely, and come back when you're ready to compare answers. Let's compare answers. There are two ways to approach this problem. Option 1 is to start with the grid, writing the terms of the polynomial in the grid, finding the common factor of the top terms, which is 2p to the second, and then using multiplication to fill in the numbers around the grid. That leaves us with two factors, 2p squared minus 14 and 4p minus 3. Notice that we have a greatest common factor in our first term. So we have 2 times p to the second minus 7 times 4p minus 3. That's our polynomial in factored form. And this is what your work would look like if you began with the grid to do factoring by grouping and then took the common factor out of the first binomial. The other possibility would be to begin by factoring out the greatest common factor of 2, leaving us with the polynomial 4p to the third minus 3p to the second minus 28p plus 21. We could take that polynomial in pink and use the grid to factor that out. Again, following the same process where we write the terms in the grid, find the common factor of the top row, and then use multiplication to fill in the numbers around the grid. In that case, we would have the factors p squared minus 7 times 4p minus 3. Don't forget the 2 that we factored out at the beginning. And so we have 2 times p squared minus 7 times 4p minus 3. And once again, no matter which path we chose, we ended up with the same result. So now you know everything you need to know in order to use factoring by grouping combined with greatest common factors and differences of perfect squares. Remember, you can learn more about factoring in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.